2023 May-June Mathematics Paper 1 exam. We will be starting with question 5. The graphs of the functions f at x equals to negative of x plus 3 into bracket squared plus 4 and g at x are equal to x plus 5 and are drawn below. The graphs intersect at A and B. Write down the coordinates of the turning point of f. We know for a parabolic function given in terms of f at x equal to a equals a x plus p, a bx plus p plus q. For such a quadratic function, the turning points are given by the value of p and q, right? Thus, however, as you can see that our turning point lies on the negative x-axis, thus this tells us that our turning point will be minus 3 and 4. 5.2. Write down the range of f. The range of f is all values for which your function is valid. All function values for which your function is valid. And this is possible from the point of turning all the way down up to negative infinity. Therefore, our range will be y is an element, let me write it as y is between 4, this is not the right way to write it, y is between minus infinity and 4, such that y is an element of real numbers. 5.3. Show that the x coordinates of a and b are minus 5 and 2 respectively. Well, for this, all we need to do is we just equate our functions f at x equal to g at x, because when you look at the graph, our functions are equal at the points of intersection, that is a and b, and in order to find the points a and b, we need to equate the functions and solve for x. Thus we have minus x plus 3 squared plus 4 is equal to x plus 5. Algebra, x squared plus 6x plus 9 all plus 4 equals x plus 5. Then you have minus x squared, minus 6x minus 9 plus 4, that's minus 5. Yes, minus 9 plus 4, that's minus 5, equals x plus 5. Taking our x's, isolating our function value and leaving 0 on the other side, we find minus x squared minus 7x minus 10 equals 0. From here, we can multiply by negative 1 to get x squared plus 7x plus 10, which is 0. Right now, writing out the factors of 10 and 1, that should give us 5. That should give us 7. That would be x plus 5 and x plus 2, which are equal to 0, which tells you that the x coordinates for the points of intersection are x equals to minus 5 and x equals minus 2. Now from here, we can pick each one of our functions. Either we can pick f at x or g at x and plug in our values of x, right? So the easiest one for that would be g at x. So plugging in g at x equals minus 5 tells us that this will be minus 5 plus 5, which is equal to 0, which is the coordinate, which tells us that the coordinate A is minus 5 and 0. Let us confirm that on our graph. Indeed, on our graph, the point A is a critical point. It's a point at which our graph of f crosses the x-axis, and it's also a point at which our graph of g crosses the x-axis, so it is our critical point. Next, we plug in g at x equals to minus 2, which will give us minus 2 plus 5, which equals to 3, which tells us that our coordinate for b will be minus 2 and 3. If we go and confirm, it does indeed make sense that b is minus 2 and 3. The next one wants us to determine the values of c for which the equation minus into x plus c plus 3 squared plus 4 is equal to x plus c plus 5 has one negative root and one positive root. So if our graph is to have one negative root and one positive root, then it would mean that our graph of f would have to shift to the right. Okay, it would have to shift to the right. Now, if it shifts to the right, looking at the distance between our points of crossing the x-axis, looking at these 2 points, looking at these distance, these are our critical points for now. These are our roots. So we are looking for a situation where we could have a graph that does something like this, okay, whereas it would have one positive root and one negative root, and we are looking for all the values of c which can satisfy that value. Okay, cool. So now when we look at it, because our first critical point, now stay with me here, because our first critical point is at x equals minus 2, what we can do is we can say the graph needs to shift at least 2 units to the right in order for it to have a positive root, in order for our graph to have a positive root. Thus, it needs to have at least 2. But now here's the catch: if it has exactly, if the value of c, or if our graph shifts to the right by exactly 2 units, then our point of contact with the x-axis will be 0, which is neither positive nor negative, right? So this essentially tells you that your graph needs to move more than 2 units to the right. Okay, it can't move exactly 2 units, therefore we are not going to be using the inclusive inequality. Rather, we will be using the exclusive inequality. Okay, so, and remember, it must move more than 2 units to the right. Okay, now the other thing is this needs to have a limit, because we have a root at x equals minus 5. Okay, so if we have a root at x equals minus 5 and we move our graph, say 5 units to the right, then it means that our graph will have critical points 0 and say maybe 0 and 3. For instance, it would have critical points x equals to 0 and x equals to 3. And remember what we said about this point: we can't have it on the x equals to 0 line. We can't have a critical point on the x equals to 0 line, because remember, our graph must have both a positive and a negative root. So here, what you would need to do is you would then need to move your graph. Let me just write that down. What question is that? That's 5.4. 5.4. So that means your graph would need to move more than 2 units. Okay, I'll just would have to move more than 2 units up, more than 2 units to the right, but less than 5 units to the right. Now, the question asks us to find for which values of C will the graph have one positive root and one negative root. Well, we already have our answer here. It essentially tells you that our root must be -5 and -2. C must be between -5 and -2. Now, the question you must be asking yourself is, why is it that our C values are negative? Now, remember, in order for a graph to shift to the right, you need to subtract. And for a graph to shift to the left, you need to add. So if your value of, say for instance, if your value of P increases, then it means your graph is shifting to the left. And if your value of Q increases, it means that your graph is shifting upwards, right? But if your value of P decreases, it means that you are shifting your graph to the left. I hope that is clear. 5.5, the maximum distance between f and g in the interval xa and xb is k. If h at x is equal to g at x plus k, determine the equation of h in the form h at x equals yada yada yada. Okay, now we are told that the maximum distance between that is k, right? Now we may thus write say 5.5, k is equal to f at x minus g at x. That is the distance between x and k. Now let's go back to the question now. That is the distance between f and g in the interval xa and xb, right? Now, if we are told to get the maximum distance, right? We are told to get the maximum distance. So from here, immediately this is telling you that you have to do something about differentiating. You need to differentiate something. Immediately from hearing the word maximum, you are looking to differentiate, right? Okay, so let's go to our differentiation steps. Okay, first let's write down that find h at x equals to g at x plus k. Is that right? Yes, that is right. Wonderful. So now, in order to find k, we need to take, what is the equation of f? That is minus x plus 3 squared, minus x plus 3 squared plus 4 equals x plus 5. Sorry, this should not be equated, but rather it should be subtracted, right? This is k, this is the value of k. Now, this simplifies out to minus into x squared plus 6x plus 9 plus 4 minus x minus 5. This is equal to minus x squared minus 6x. Now, negative 9 plus 4 minus 5, that's going to be negative 9 minus 1, and that would be minus 10 minus 6x. Okay, this will be minus 6x minus x, that's going to be minus 7x, and then it's going to be minus 9 plus 4, that's going to be minus 5. Okay, minus 5 minus 5, that's minus 10. And then, now, since we are told to look for the minimum, for the maximum distance, which is k, we must then find let me see. So we must thus find the value of the maximum, right? We must thus find the value of the maximum. The maximum occurs at the point where k prime is equal to 0, and k prime, what is going to be k prime? K prime will be the first derivative of our graph of k, and that will be minus 2x minus 7 equals 0, which tells you that x is equal, it tells you that minus 2x is equal to 7. X is thus minus 7 over 2. Okay, wonderful. Now, since we know that the maximum occurs at the point where x is equal to minus 7 over 2, we take this x and we plug it in back to k. Okay, and when we plug it in, what we're going to have is k at x equals to minus 7 over 2 is equals to minus 7 over 2 squared, minus 7 into minus 7 over 2 minus 10. Plug that into your calculator and it gives you that k is equal to 2.25. Yes, k is equal to 2.5. Therefore, our graph of h at x, which is equal to g at x plus k, will be given by x plus 5 plus 2.25, which is equals to x plus 7.25. And that is that for question 5. All right, wonderful. Now moving on to question 6, I'm just gonna erase this here so that it doesn't get in the way. I'm gonna delete that. Okay, question 6 is a fun one. Question 6 is a financial mathematics question. Now, question 6, 6.1. We are told that a company bought a photocopier for 150,000 rands on 1 July 2022. All right, we are told the photocopier costs 150,000 rand when it is bought. So immediately this tells us that the present value or the purchase value of this photocopier is equals to 150,000 rand. Okay, this is when on 1 July 2022. They will use the old photocopier as a trade-in when they replace it with a similar new photocopier in 5 years time on June 30, 2027. Okay, so they are going to purchase a new photocopier in 5 years time, right? In 5 years time, our n is equals to 5 years. Okay, wonderful. Now let's look at the first question, 6.1. 6.1.1. The average rate of inflation over the next 5 years will be 6.5% per annum. Determine the price of a similar new photocopier in 5 years time. So now we are going to determine the value for which the value or the cost for the photocopy machine in 5 years. And what formula we'll be using? We'll be using the compound interest formula. Why are we using the compound interest formula? Because of inflation, right? This is a question that has inflation. Immediately that should tell you that you are dealing with a compound interest kind of question. Okay, and our formula for inflation is A is equal to P into 1 plus I to the power n, where A is the value that you are looking for, which is the future amount. P is the present amount for which you bought the photocopier. I is the interest value, and n is the number of years. Okay, Now, remember, for the interest value, you do not write it as a percentage, but rather you write it as a fraction out of 100, because that is what a percentage is. Okay, now plugging in our values, we know that P is 150,000. 1 plus 6.5% is 6.5 divided by 100, all to the power of 5, which is our investment period, or the amount of time that it will take, or the duration essentially over which you are evaluating the price. This will then be equal to 205,513 rands. Okay, now the second question, 6.1.2, wants us to calculate the trade-in value of the old photocopier after 5 years if it depreciates at a rate of 9% per annum on a straight line method. So already the question tells you what formula to use. What formula are we using? Not the compound interest formula, but the linear interest formula. This is equals to P into 1 minus I multiplied by N, and that's it. You just plug in your numbers. 1 minus 9 over 100 multiplied by 5 years, and that is 82,500 rands. Okay, wonderful. 6.1.3. The company set up a sinking fund to cover the replacement cost of the new photocopier. Okay, already that tells you need to figure out what is the value of the sinking fund through the sinking fund formula, where SF is equals to the amount that we project we will be buying the photocopier with in 5 years, minus the trade-in value. Okay, wonderful. Now we are told that the fund earns interest at a rate of 7.85% per annum, compounded monthly. The company made its first deposit on 31 July 2022 and will continue to do so until 31 May 2027, 1 month prior to the new photocopier being bought. How much should be deposited to the end of each month so that the company will be able to buy a new photocopier? All right. Now, since we are dealing with a sinking fund, we need to know how much is the value of our sinking fund. Okay, our value for the sinking fund will be the 205,513 minus the 82,500, and this will be 123,013. Okay, now the next thing is, seeing as we are looking for how much we need to be depositing at the end of each month, we are looking for essentially the amount of the installment that we're going to be paying to in order to be able to buy the new photocopier, right, using the sinking fund. Okay, because remember that the sinking fund is to be deposited into the thing. Okay, so yeah, we are going to be using the future value formula in this case. Because why are we using the future value formula? We are using the future value formula because we are looking for the installment that is going to be paid once we look at the future value of the item. Okay, we need the installment that is going to be paid to cover the future value of the item, and we already know what future value is going to be covered. It's going to be the sinking fund amount, which is 123,000. Now you may be asking yourself, this guy is saying a lot, he's talking too much. What exactly is he saying? Let's go through it. start with our formula for the future value, which is x into 1 plus I to the power n. Remember, because y, it is compounded monthly. It is given in your statement that your interest is compounded monthly. Okay, to the power n minus 1 all over I. Okay, immediately by rewriting our formula to isolate x, we can immediately tell that x is equal to the future value multiplied by the interest divided by 1 plus I to the power n minus 1. Okay, now what is our future value? Our future value, or our fund at this point, is 123,013 multiplied by our interest rate. Our interest rate is given by 7.85%, sorry, so that will be 7.85 divided by 100 all over 1 plus 7.85 over 100 to the power. Now, this says, when you look at it, between the 31st of May 2027 and the 31st July 2022, there are exactly 59 months. Okay, because this is 5 years, there are 60 months, but because we are buying, we are looking at the value of the photocopier, or how much you're going to be paying until 1 month before we actually buy the photocopier, then it essentially tells you that our thingy is going to be, our duration is going to be 59 months. Okay, so that's going to be to the power 59 minus 1. Okay, plug that into your formula, and now, okay, there seems to be, I made a bit of an error here. Okay, now we need to remember that this is a problem that has been given to us not in terms of years but in terms of months. Now, because we are seeing that the problem requires us to calculate over a period from the 31st of July 2022 to the 31st May 2027, this is over a period of 59 months. But because we are used to writing our n, we are used to writing n in terms of the number of years. Because we are using months now, we're going to have to divide I by the number of months that there are in a year. So this is going to be I divided by 12. Okay, so meaning every I will have to be divided by 12. Okay, this will all be divided by 12. Let me put that in brackets so that it's not confusing. Okay, so then that is going to be 1 plus, into bracket, 7.85 over 100. Sorry about that. Divided by 12, all to the power of 59 minus 1. Now coming back to plug that into our formula, or into our calculator rather, that gives us a value of 1,704.01 rands. And finally, the last question. Today, Andrew borrowed 200,000 rands from a bank. The fact that it's telling you about borrowing, it's about lending, it already tells you that you are going to use the present value formula, because why? This is a loan. So Andrew borrowed 200,000 rands from a bank. The bank charges interest at a rate of 5.25% per annum compounded quarterly. Okay, compounded quarterly. They're not going to give us this information if it wasn't important. Okay, now Andrew will make repayments of 6,000 rands at the end of every 3 months, meaning at the end of each quarter. Okay, at the end of each quarter, Andrew is going to make payments of 6,000 rands. This is Andrew's installment. This is the amount of money that he's going to be paying back in order to cover his loan over whatever period that it will take for him to settle his loan. Now, his first repayment will be made in 3 months from now. How long in years will it take Andrew to settle the loan? Now remember what we said? We said this is a present value question. Oh, wrong pen. 6.2, it's a present value question where the present value is given by x into 1 minus 1 plus I all to the power negative n all over I. Okay, now we know the present value of the loan is 200,000 rand. 200,000, right? And we know that the installment that he's paying is 6,000 rands. 1 minus 1 plus. Our interest rate is 5.25% compounded quarterly, so that's going to be 5.25 over 100 divided by 4. Okay, divided by 4 all to the power minus 4 into n, because why? It's compounded quarterly, right? And n is the number of years that it will take. Okay, and 4 is the number of quarters in a year, which is like 4 quarters. Okay, all divided by 5.25 over 100 multiplied by 1 over 4, which is essentially division by 4. Okay, if you do your math right, this should end up giving you something that looks like 7 over 16 is equal to 1 minus 1 plus 0.0525 divided by 4 to the power minus 4n. Okay, again, doing your math right, this should be 9 over 16 is equal to 1,621 divided by 1,600 to the power minus 4n. So from here, what we need to do is we need to use log laws. Now, when you're using log laws, you know that if you have a to the power of x is equal to b, you can then say x is equal to the log of a, which is your base, into b. Okay, so using this rule, this tells us that the log of 1,621 over 1,600 into 9 over 16 is equal to minus 4n. Now let me write this nicely. Minus 4n is equal to log 1621 over 1600 into 9 over 16. Okay, from here, just punch into your calculator. This is going to give you approximately n equals to 11.03 years. That is quite a long time to be paying off 200,000 rands for a loan. And that brings us to the end of question 6, ladies and gentlemen, theys and thems, and everybody included. Moving on to question 8. Just going to remove that so that it doesn't get in the way. Question 8 should be a fun one. I know most students really enjoy the introduction to calculus questions. Well, let's get right into it then. Question 8, 8.1. No, we didn't do question 7. Supposed to be doing question 7. Yes, supposed to be doing question 7. Sorry about that. I hadn't realized that I had skipped a question, but no matter. My man, come to question 7. 7.1. We are asked to determine f at x prime from first principle if f at x is equals to minus 2x squared minus 1. Now, we know that the one thing that you must do if you have f at x is equal to minus 2x squared minus 1, what must you do in order to find the f prime? You need to use the formula f prime at x is equals to the limit as h tends to 0, okay, of f at x plus h minus f at x divided by h, okay? Now, I would advise that the first thing you do is you find what this f at x plus h is. Now, what f at x plus h is, it's essentially telling you wherever you see the x on the formula, you just replace it with f x plus h, okay? So we're essentially going to write f at x plus h is equal to minus 2 into x plus h squared minus 1, which is equal to minus 2 x squared plus 2hx plus h squared minus 1. And finally, this will be minus 2x squared minus 2h, sorry, this should be minus 4hx minus 2h squared minus 1. Right? Now, substituting this into our formula, this tells you that f prime at x is given by the limit as your h tends to 0 of minus 2x squared minus 4hx minus 2h squared minus 1 minus, you take the entirety of f at x and you substitute it in there, all divided by h, okay? So now it's a matter of doing our manipulations, okay? Let's get rid of the brackets first. So that's going to be minus 2x squared minus 4hx minus 2h squared minus 1 plus 2x squared plus 1 all over h. From here, we can already tell that 2x squared and 2x squared cancel, minus 1 and positive 1 cancel, such that we are left with the limit as h tends to 0 of minus 4hx minus 2h squared all over h. When we look at this, we can see that h is a common factor. Then we can take out h as a common factor, such that we are left with 4x minus 2h over h. Our h's cancel each other out. And finally, when we get to the stage now, we may just substitute the value of h tends to 0 as h equals to 0 into h. Thus, we are left with minus, sorry, this should be positive, minus 4x plus 2 into 0, which is equals minus 4x. And confirming that from using the power rule, we know that if we have a function g at x is equals to axn, we know that the derivative will then be equals to anx to the power n minus 1, right? Now let's apply that to f at x. We can say f prime at x is thus equal to minus 2, right, which is our n, into 2x to the power 2 minus 1, the derivative of a constant is 0, thus we have minus 4x. We have confirmed that our solution is correct. Wonderful. Now 7.2 wants us to determine f prime at x if it is given that f at x is equal to minus 2x cubed plus 3x squared. Okay, that's 7.2.1. Our f at x is equals to minus 2x cubed plus 3x squared. Using our power rule, that's going to be minus, okay, let me do this step by step. This is going to be minus 3 into 2x to the power 3 minus 1 plus 2 into 3x to the power 2 minus 1. This will thus be minus 6x squared plus 6x. 7.2.2. What's that asking for? dy by dx if y is equal to 2x plus 1 over 4x. Okay? Now, we are given that y is equal to 2x plus 1 over the square root of 4x. Okay? Immediately that tells you can just say 2x plus 1 over 2 to the power x to the minus 1 over 2, because remember, square root of x is equal to x to the power 1 over 2, and 1 over x squared is equals to x to the power minus 2, which tells you that 1 over square root of x is equals to x to the power minus 1 over 2. It's just a little bit of enrichment. Now that we have our y in a much more comfortable sense, we can then determine dy by dx, which is then going to be equal to the derivative of 2x with respect to x will be 2, right? Plus, we then multiply the minus 1 over 2 into 1 over 2x to the power minus 1 over 2 minus 1. And finally, your answer will be 2 minus 1 over 4x to the power minus 3 over 2. Great. Now, let's look at 7.3. 7.3 tells us that the graph of y equals f at x has a minimum turning point at 1 and minus 3. Okay? Determine the values for which f is concave down. Okay? Here, it tells you that the graph y is equals to f prime has a minimum turning point at 1 and minus 3. Has a minimum turning point at 1 and minus 3. So meaning essentially our graph could be something like this, where our turning point is at 1 and minus 3. Or we could have another graph that is something like this, with a turning point and 1 and minus 3. Please don't mind my drawings. I am horrible at drawing. Okay, so now we are asked to determine the values of x for which f is concave down. And we can see that the value of x, which we can see that this is a bit of a wild question. The graph of y is equals to f at x as a minimum turning point at 1 and minus 3. Okay. Determine the values of x for which f is concave down. Okay, now we may then determine that f is concave down when x is less than 1. Okay. Wonderful, wonderful. And now we will be moving on to question 8. Okay, once again, I'll just remove all of this to make space for our workings. Question 8. Given f at x is equal to x cubed, so this is a cubic function, it's equals to x cubed plus 4x squared minus 7x minus 10. Write down the y-intercept of f. That is easy, you can just see that right there. Y is equal to minus 10. 8.2. Show that 2 is a root of the equation. Okay, now we know that f at x is equal to x cubed plus 4x squared minus 7x minus 10. In order to show that 2 is indeed a root of the equation, we may then substitute x equal to 2 into our equation, such that we have 2 cubed plus 4 into 2 squared minus 7 into 2 minus 10. And that will be equal to 0. Therefore, 2 is a root. X equals 2 is a root. 8.3. Hence, factorize f at x completely. Now, we know that x equals 2 is a root, which immediately tells you that x minus 2 must be one of the factors, please excuse me, the factors of our equation. It should be one of the factors of our expressions. Okay, so this means that f at x is equals to x minus 2 multiplied by some other trinomial. Okay, and this trinomial will be given by x squared plus 6x plus 5. Now, this can be found in the long division method, and for those that are interested, it's this a bus method that most of you do not like. And then this is x cubed plus 4x squared minus 7x minus 10. Now, if you do the long division method using this little bus notation, you will find that the root that satisfies this equation is x squared plus 6x plus 5. I will leave that to you to do as homework. Just kidding. But yeah, that is how you find the roots using the long division method. Then, looking at our trinomial must then also factorize to a set of 2 binomials. Okay, now we have x squared plus 6x plus 5. We need a factor of 5 and of 1 that can give us 6. So immediately that tells you it's x plus 6, x plus 5 and x plus 1. And that is your final factorized answer, right? 8.4. 8.4, we are asked we are told it is further given that the coordinates of the turning point are approximately at 0, 0.7 and minus 12.6 and minus 3.4 and 20.8. Okay, draw a sketch of F and label all intercepts and turning points. Now we already know our intercepts. Since we already know our intercepts, we can just plug those in. We know one of our intercepts is x equals to minus 5. Another one is x equals to minus 2. And the next one is x equals minus 1. And the final one is x equals 2. Okay? And from there, we already know that because we have our roots, we may thus write our graph like that. It starts concave up because the value of it starts concave down because our value of a is positive. Now, since we see that and we know that our y-intercept is minus 10 and we have two turning points. Now we're just asked to label those turning points. The first turning point is 0.7 and minus 12.6, which is right down here. And the second turning point is minus 3.4 and 20.8. And there is our graphs with all required turning points with all intercepts and turning points. And question 5, 8.5. So for question 8.5, we are told to use the graph to determine the values of x for which f prime at x is less than 0. Okay, that's 8.5.1. So for 8.5.1, for which values of x is f prime at x less than 0? We are looking for points on the graph for which the gradient is negative. And the negative gradient occurs when the graph is slanting backwards. So this point right here. And that occurs when x is between minus 3.4 and 0.7. Because those are our turning points, remember? Those are our turning points. That's where the concavity of our graph changes. The turning points are the points at which the concavity of our graphs changes. So that's going to be minus 3.4 less than x less than 0.7. 8.5.2, we have, what is the question for 8.5? The gradient, we are asked to find the gradient of a tangent to f will be a minimum. Use your graph to determine the value of x for which the gradient of a tangent to f will be a minimum. Okay? We are told this keyword minimum, which immediately tells you you need to differentiate. Now, because you are differentiating and you are looking for the gradient of a tangent, you need to find the equation of a straight line, because a tangent is a straight line. Now, this straight line can be given by the second derivative, so that tells you we need to differentiate. We need to find the point for which f double prime at x is equal to 0, right? We know that f at x is equals to x cubed plus 4x squared minus 7x minus 10. Therefore, d by dx of 3x plus 8x minus 7, 3x squared plus 8x minus 7 is equal to 0. Therefore, we have 6x plus 8 equals to 0, 6x equals to minus 8, x equals minus 8 over 6, which is minus 4 over 3. Okay, that is the value for which the gradient of a tangent to f will be a minimum. Okay, we are asked to find a value for which f prime at x multiplied by f double prime at x is less than or equal to 0. And this is going to be the interval 8.5.3. Using your graph, this is going to be the interval where x is less than or equal to minus 3.4. And actually, this should be or, where x is between minus 4.33 and 0.7. Okay, because here the gradient of our straight line will be, here the straight line will have a positive gradient, and the gradient itself, or f prime at x, will have a negative gradient, and between these two intervals you will have a product being less than or equal to 0. And that is where I would like to leave our lesson for today. I will see you next time for the rest of the question paper.